Assalamualaikum warahmatullahi wabarakatuh. This is lecture presenting for chapter weathering, and this is the explanation for weathering grades. So you have already read about weathering divided into two processes. Number one is physical weathering and number two is chemical weathering. And when you see outcrops in the environment, you will think about what caused the hill or the mountain to become like that. And when you know that outcrops, when exposed in the environment, it will experience some weathering process, and this weathering process will result into weathering grades. So let's see what is weathering grades is all about. So this is the slide showing that you have different types of weathering. We have the same soil, the same rock in one mountain, for example, or you call it as outcrops. But when you make cut for that particular mountain, you can see different grades or different texture of rock. Okay, for example, okay, if you can see this mountain, okay, at the top of the mountain or the hill, we have 100% soil, meaning that the whole rock has been decomposed, and the last result of that process is the rock will become soil. So when you go deeper to that particular hill or mountain, you can see mixture of texture. Okay, this is the whole chunk of rock that's still not yet weathered, and the dotted part is all soil. So when you go deeper to the hill or the mountain thickness, you can see more rock and less soil. So when you go to the lowest part of that particular mountain or hill, you can see a lot more of rock to compare to soil. It is meaning that the rock that exposed most to the environment will going through experience of extensive weathering. So because of that, the top of the mountain or the hill, eventually we have the product of soil. So this is how we will define engineering. We will define into grades. So this is for granite, metamorphic, and sedimentary or carbonate. Okay, what you can see that the result of the weathering process is always the same. The topsoil is the most exposed to the environment, and we can have everything is soil. Every rock has been disintegrated into soil. So if you dig deeper, the same thing will happen. Either that is the granite, metamorphic, or sedimentary rock. So this is how we explain about grades. Okay, if you can see everything is soil, we call it as grade 6. So if we have some of the texture is rock, or if you see some of the texture is rock, we call it as grade 5. So you have more rock to compare to the soil. You have grade 4, and then you have grade 3. And if you have everything is rock, there is no evidence of weathering happen, we call it grade 1. So the more you get your soil in that particular layer, that will be the bigger grades that we will name it. Okay, this is the actual on-site the weathering grade for, I believe that this is some of sedimentary or igneous rock. Okay, on this part, okay, if you go to this area and you bring your shovel, it will be easily removed because this part is 100% soil. So this is the part that are still ongoing the weathering process, and we call it as grade 5. And this part is thicker and stronger to compare to other part. That one is grade 4. So you will see a lot more of non-weathered area, that will be grade 4. And of course, beneath this hill we can get grade 3, grade 2, and also grade 1. So this is another way when you go to anywhere that is surrounded by mountain area, or you are going to practical and your company do the site clearance process, you can see a lot happening on site. Okay, not the site that you clear you can get 100% soil. Okay, some of the site that you make it clear, you can still see a lot of rock that are not going any weathering process. This is the whole chunk of the rock that you can see when you do the site clearing process. As you can see in this picture, this is the lorry, so you can do the comparative imaginary about the size of the rock and the size of your site, and when you are there at site. So for this example, as we have already explained, if everything has been weathered and you can see everything is soil, that is grade 6. So this one is grade 6. And we have some soil, some rock. This is grade 5. And you have more rock to compare to your soil, will be grade 4. You have a lot of the rock still happening and still not going to the process of weathering. You can classify that as grade 3 or grade 1, grade 2 or grade 1. Okay, how you explain for this grade? You can number the grade, but how you explain this to people that want to understand what is grade 6 is all about. So we can use this explanation to explain about grade. If you have grade 6 in Malaysia, what we always or commonly see on site, that will be residual soil. And how you explain about grade 5, this one is grade 5, you can say that particular part has completely weathered, but there is still some trace of rock. And number 4, you will define as highly weathered. Grade 3 is moderately weathered. Grade 2 is slightly weathered. And grade 1 is fresh rock. Or this one, you have already two types of explanation, 1B and 1A. Grade 1B is fairly weathered, and grade 1A is fresh. Okay, we need to know this one because you do the site clearing and then you do the site investigation. All of this you must report to your superior or engineer. So engineer will decide what is the method what is the suitable method to use on site for these particular types of soil or area. If you want to have a detailed explanation about the grade symbol, okay, this is the grade symbol and how that grade symbol define, and then when you go on site, how you identify your material or your site area. So you can use this table, which is the classification of rock material, weathering grades, sedimentary and metamorphic rock, according to Enon 1977. But it's already accepted if you can have these two columns, you know the number of the grades and you know the name or the description of that particular grade. So the way you explain, you can explain using words like this, and of course you can use drawing to define what is the grade is all about. So you can add another table for this particular example. So you can draw all the dots is actually 100% weathered rock, so you have more of soil. So for grade 5, this is how you draw it. And for grade 1, this is actually a fresh rock, there is no weathering happening. But this one you can, for grade 1B, you can show some weathering has occurred. So that is the way you can describe the grades for weathering. So next you can ask question. If we have weathering, we have the whole thing is rock, and then we have weathering grades. And that question is how actually this weathering process happen in actual case. So we need to know about the rates of weathering. Is it very fast or is it very slow? So there are few factors which determine the rate at which the exposed bedrock being weathered by various agents of weathering. Okay, we already know the agent of weathering, and this agent of weathering depends on the region, depends on the geography. Okay, meaning that if you are in Malaysia, the agent of weathering, of course, you know, heat and also water, because we have heat and also rainy season throughout the year. And if you go to east region country like Arab and so on, so there is a lot more of heat, and then of course wind at the desert area. So that will be the component of weathering agent. If you go to the temperate climate, we have 4 seasons. So you need to include about the ice or the snow, because of at that temperate climate you will have the agent of freezing and thawing process. Okay, what are the factor affecting the rates of weathering? Number 1 is composition of rock. So mineral and chemical composition is one of the most important factor. Okay, cementing material, for example, igneous rock, are resistant to mechanical weathering but more susceptible to chemical weathering. Okay, because we know igneous rock is from magma. When this magma solidified, it will produce a very huge chunk of rock, and everything is cemented together. So it is resist the mechanical weathering, but we can obviously see chemical weathering will result to the byproduct of the igneous rock weathering process. For sedimentary rock, for example, using dolomites and limestone, most of them are decomposed by carbonation and solution. So you know that limestone is kind of salt. So if you pour water, this salt is actually can dissolve with water. Okay, next is the physical condition of rock. Crevices, crack, hole will allow weathering agent penetrates and eventually disrupt the rock. Okay, I give you the example. If you expose this rock to the environment, this is 100% rock without any crevices and hole, and you compare with this type of rock which have some hole there, some crevices there, and some crack everywhere on the surface of the rock. So this is a two different physical condition of rock, and we know that this one will weather quicker to compare with the other rock. Okay, number 3 is the topography. Weathering is more rapid at slope area. At high altitude will increase the rate of weathering due to low temperature and high rainfall intensity. So you can draw a mountain or hill, and we know that this is the top of the mountain, and the top of mountain have high altitude and very low temperature. But when it's raining, this area will get a lot more of water to compare to the downhill. Okay, number D is climatic condition. I already mentioned this. This is about the geography where the rock is positioned. Climate which have abundant rainfall and moist will accelerate the weathering process, especially chemical weathering. Dry or cold weather are usually accelerate the physical weathering. So if you have more water, your rock is susceptible to chemical weathering process. And in Malaysia, why we have a lot of limestone, so we can produce cement and also aggregates, a kind of that engineering material because of we are in the tropical region. We receive a lot of rainfall, and the rock exposed to consistent heat throughout the year. Most of the soil that cover the earth are formed by the weathering of various rocks. In terms of geologies, we have different definition of soil from the perspective of geologists and then from the perspective of engineer. Okay, both of the profession define soil differently. For geologists, soil is defined as weathered material that will support the growth of rooted plants. So the thinking of geologists is most of the time is about to nurture of plant. But in terms of engineer, what we understand by soil, because we are more concerned about the development of the area, we define the soil is simply unconsolidated material which typically disintegrated in water. And also engineer understands soil is the material on site that you can remove using shovel, or maybe you want to use some mechanical equipment as well. Soil and superficial deposit can either be residual or transported in origin. So let's see the term residual and then the term transported. Okay, residual is from the words residue. Okay, whatever left on that particular area, meaning that your soil is not going anywhere. But in terms of transported, the meaning of transport is to be relocate, meaning that from point A, the soil are going to another place, which is point B. So when there is movement happen, we are explaining that is transported soil. So let's see in terms of residual soil. Okay, what is the meaning by residual soil? Okay, residual soil is developed in situ. Okay, meaning that on site, and meaning that the soil have never experienced going anywhere. So it is in the simplest, the rock when the soil become rock and then weathered and become soil, it is in the simplest. Their characteristic depends on the kind of bedrock or grade 1. Okay, bedrock is the grade 1 rock from which they are derived. Residual soil deposits are common in humid tropical countries. So, if you can see a lot of soil in Malaysia, that is actually residual soil. So, next is transported soil. To contrast the residual soil and transported soil, residual soil is not going anywhere. Transported soil going some movement, and at the end the soil is settled in one particular area, and that is what we call as transported soil. Transported soil are superficial deposit which accumulates due to erosion, transportation, and deposition of weathered residual soil or bedrock. Common superficial processes and their resulting deposit are three types of transported soil is colluvium, alluvium, and glacial drift. For colluvium, result from process of creep whereby soil and weathered bedrock slowly move downslope due to gravity. So this is more to the hillside. Alluvium includes all sediment deposit by stream. The deposits are stratified into layers of silt, sand, gravel, and clay. This is more to the location of riverside. You can see a lot of alluvium. Glacial drift includes all deposit formed by glaciers. So this is, of course, we cannot see this example in Malaysia because we are not in the temperate climate region. So next, when we already learn about the rate of weathering, is have a lot of factor to accelerate the weathering. Now you need to learn about erosion. Erosion is one of the important agent of removal and transportation of superficial material, which is the product of weathering. Materials that are susceptible to erosion not necessarily from weathered soil but any unconsolidated surgical deposit. There are three agents of erosion. Number one is water, wind, and also glacial ice. Okay, you can see this picture, how erosion will causes the rock to break down. Okay, this is the condition of your site exposed to the environment, and erosion or water and transport move the sediment downhill to another place. Okay, you have a lot of rock, okay, at the lower part of the rock. It is not going anywhere, but when the erosion agent comes, it moves the rock to the lower part of the hill. So you also have the erosion by water, the most important type of erosion in terms of the amount of sediment removed from land surface, such as erosion in streams and river channel. Rivers are formed as a result of runoff and of many different types. There are few factors that determine the type of erosion. Okay, number one is abrasion. Depends on load in river and amount of material carried by water. For example, sand grain, pebbles or boulders which act as cutting tools that can deepen or widen the river bed. Effective where velocity of river is rapid, river loads are heavy and roll along the bottom. So you have that kind of accelerate and very fierce erosion happen when you have a very high velocity of river, and that river have boulders and pebbles you that can cut through the riverbed. And then you have the solution of corrosion. Water as solvent and have corrosive effect on rocks, especially when water contain acids that could attack the rocks and dissolve the minerals in the bedrock. For example, carbonic acid from vegetation may attack rocks such as limestone and dolomite. C is attrition. Boulders and rock fragments are worn by friction and may be broken down as they are rolled and carried along in water. So, okay, of course, we have the erosion rates by water. There are three factors that affect the rate at which running water will erode. Number one, stream size. Large volume of water can carry larger loads and therefore very effective during flood stage. Number two, gradient and velocity. Slope at which river flow will affect the velocity and usually is higher at the source and lower at estuary. Velocity is actually higher at rivers with straight channel, free of obstacles, and at steep gradient. Straight and narrow channel will erode more effectively. Number 3. Nature of load. River with many obstacles will reduce velocity and carrying water. So in terms of deposition, load will be deposited when competency and capacity of river is decreased. For example, when the river decrease in volume, loss of velocity, obstacle in stream channel, widening of stream bed, overloading, freezing, and also reduction in stream gradient. So we do have another erosion by wind. The effect of erosion of soil by wind is similar as erosion by water, where it is capable to lifting and transporting loose sand and dust, but its ability to erode solid rock is limited. Very fine to fine sand are most susceptible to wind erosion. It is responsible for the formation of the great desert like Sahara and other deserts. Few variables that contribute to the effectiveness of this type of erosion are velocity, duration, and length of open area without obstacle over which the wind blows. Erosion can be by deflation, blowing away process. Okay, this is how deflation happens, and it so can be from deposition. So the load will be deposited when velocity is decreased due to the obstacle of rain. Types of wind deposit are dunes, formed when there is a sudden drop of speed of wind, forming hill of sand, usually formed in area where there is sufficient amount of loose unprotected sand and strong wind. Okay, this is how it's happened. And then you have loss. Deposit of wind-blown silt that accumulate slowly and ultimately blanket large area. Okay, well known for its ability to form fine texture, fertile yellowish soil in areas of sufficient rainfall and important for agricultural purposes. So this is the lowest deposits. We like this deposit, this kind of soil, because of it supports the life of plantation. Okay, you can review your understanding about this weathering topics, so you can answer all of these questions. Can you describe the following terms: mechanical weathering and chemical weathering? You can describe three factors that determine the rate of rock weathering. How does weathering differ from erosion? How do organisms contribute to mechanical and chemical weathering? What is soil degradation? These three types of soil degradation. So that is all about the weathering process. And okay, this is all for chapter 5 for weathering of rock. So we have another 2 chapters to complete for this semester. Okay, thank you all.